Hello guys, and welcome back to a new video. Today's video is going to be on integration by parts. You may be wondering, what is integration by parts? Integration by parts is basically a way of integrating things like, the integral of e to the x times by x squared dx. Now, usually this would be a lot more difficult to do. For some of these integrals, you could use u substitution, but other than that, there's not really a clear way on how to do it. So that's why we have integration by parts. Now, integration by parts is sort of like decomposing an integral. So let's say you've got the integral u dv, right? So the integral of u and then dv, right? In integration by parts, you can actually make this u times v minus the integral of v du. Okay, so I'm going to show you an example, a very rough example of how this can be useful. Alright, so let's say we've got the integral of e to the x times by x to the n, then dx. So how would we do this? Well, first we would use this up here to help us. So in this case, we are going to set u equal to x to the n, and we will set dv equal to e to the x dx. Okay, so let's write that down. U equals x to the n, and dv equals e to the x dx. Right? Great. Now we can do this part. Alright? But first, we need to find what v and du are. So let's start off with du. Du. How would we do this? The way we would do this is by differentiating u. So the derivative of u in terms of x. So du is going to be, what is x to the n? What is the derivative of x to the n? The way we can do this is the power rule. It's really easy. N times by x to the n minus 1. Perfect. So we can put that in after we find what v is equal to. V. So to do this, we just need to take the integral of e to the x dx. V is just equal to e to the x, because the integral of e to the x dx is just e to the x. Okay, so doing this, we can use this part now. So let's do that. Okay, u times by v, x to the n times by e to the x, okay? Minus the integral of v, e to the x du. Du is n x n minus 1 dx. Alright, so let's see what we can do next. Well, x to the n times by e to the x can stay. So we'll write that in, because there is nothing more we can really do with that. Now minus, and if you see, we can move this n to the front, as n is a constant. Minus n times by the integral of e to the x to the n minus 1 dx. Okay, now it sort of depends what n is equal to. So for this case, to keep it simple and short, because there's going to be more happening later, we'll say n is equal to 1, okay? So that means we have x to the power of 1, which we can just write as x, and then e to the x minus 1, so we don't need to worry about writing it, minus the integral of e to the x of x to the 0, which is just 1, so we don't need to write it down, of e to the x dx, okay, which equals x e to the x minus e to the x plus c. Okay, so we can factor this because both expressions contain e to the x, so we can factor it and then just add the constant of integration. So x minus 1 and then factor out the e to the x, and then add the constant of integration. So that's basically how to do it, and n can really be anything, and then you just sort of work through the rest of it. Okay, now we're going to try some more complex integrals, we'll say. How about we try this one? The integral of x times by tan to the negative 1x tangent to the negative 1x arctangent dx. How would you go about solving this? Well, we can do this. The integral of u dv equals uv minus the integral of v du. So the first thing we're going to want to do is find what dv and u are. So for this case and most cases, you usually want to make the trigonometric component equal to u. So u equals tan to the negative 1x, or arctan. Alright, and then dv equals x dx. Alright, so here we can easily see that v is going to be equal to the integral of x dx. So this is x squared. What? Oh, no. No, sorry. No, oopsies. Oh, okay. So, yeah, we can easily see that this is x squared over 2. Alright, now we want to find du. So we are going to differentiate arctan. Alright? So what is the derivative of the derivative of tan to the negative 1 is 1 over 1 plus x squared dx, I think. Yeah, it's that. 1 over 1 plus x squared dx. Alright. Now, we can just plug it in here. Okay, so uv tan to the negative 1x, or arctan, times by v, x squared over 2 minus the integral of v du. So x squared over 2, right, times by, and then du, which is 1 over 1 plus x squared dx. Okay, so let's rewrite this. Arctan, okay, times by x squared over 2, or x squared times by 1 over 2 minus the integral of x squared over 2 times by 1 over 1 plus x squared dx. Well, here you might be able to see that the x squared over 2 is the same as 1 over 2 times x squared. So we can move 1 over 2, a constant, to the front of the integral. 1 over 2 integral of x squared times by 1 over 1 plus x squared dx. Great. So now we'll write that. Arctan x squared times 1 over 2 minus 1 over 2 integral of x squared over 1 plus x squared. Now, here, you might be wondering, what to do? Well, x squared is actually the same as 1 plus x squared minus 1. Okay, do you see where I'm going? The positive 1 and the negative 1 cancel out, so we get 0. So x squared plus or minus is 0, which is just x squared. So we can actually put in x squared plus 1 minus 1. Okay? So the integral of x squared plus 1 minus 1, okay, over 1 plus x squared dx. Now you might be able to see x squared plus 1 in the numerator and x squared plus 1 in the denominator is a pretty good sign. It means that we will be able to divide. Alright? So, what we're going to do is this. So remember how, let's say, I'm trying to think of a variable to use. A minus B over C is the same as A over C minus B over C. Well, that's what we're going to use in this case here. So, let's rewrite the entire equation. Arctan x squared over 2 minus 1 over 2, and then the integral of x squared plus 1 over x squared plus 1. That's 1 because all the terms cancel out nicely. So 1 minus 1 over 1 plus x squared dx. Okay? So now the path is quite clear going forward. There is a subtraction sign here. So we can take the integral of 1 and then minus that by the integral of 1 over 1 plus x squared. So let's do that. Equals tan to the negative 1x. And x squared over 2 minus 1 over 2, right? Integral of 1 dx minus the integral of 1 over 1 plus x squared dx. Alright. So, now, actually, we can do this. So arctan, oopsies, I almost wrote arctan. I need to. Also, guys, I'm sorry about not posting videos for a while. I've been quite busy. I've been also learning a lot about Calculus 3, and I'll be able to drop some quality videos on that topic soon. So, yeah, get excited. X, because the integral of 1 dx is just x. So, and then minus, and then you might be thinking, oh no, what is the integral of 1 divided by 1 plus x squared? Oh no. Well, actually, if we come back up here, the derivative of u, which is tan to the negative 1x, is 1 over 1 plus x squared dx. So that means that the integral of du is u, and so that means that if du is 1 over 1 plus x squared dx, oh my gosh, it's just going to be u, which is tan to the negative 1x. So let's write that. Minus tangent to the negative 1x dx. Okay, so now we can distribute the negative 1 over 2 into x minus arctan x. So this will enable us to factorize it, as we also have a 1 over 2 in the arctan and x squared. So let's do that. Equals 1 over 2 arctan x squared, and then minus 1 over 2x. You need to be very careful with these negatives. I have made so many equations wrong, especially integrals, by not thinking when I distribute. Because you get to the end of an equation and you're like, oh, thank God, all the hard stuff is done. And then your mind sort of just goes on holiday and you forget to add the constant of integration or muck up a negative times a negative. So be very careful with that. Okay? Positive 1 over 2 arctan. Don't forget the constant. So now we can actually factor out the 1 over 2. 1 over 2 arctan minus x plus tan to the negative 1x plus c. So let me just check that. Yep, I think we're correct. So that is how to do the integral of x tan to the negative 1x. our next integral is going to be something a bit different. It's going to be the integral of x natural log x dx. Okay, so the reason this is a bit different is because it's got a natural log. They're actually not that bad integrating with, so let's do it. Okay, so first we need to get u, v, du, dv, all that. So we're going to set u equal to the natural log of x. The reason we're doing this is because the derivative of the natural log of x is 1 over x, and yeah, okay, so that means that du equals 1 over x dx. That's a lot easier than finding the integral of natural log of x. So let's do, that means that dv equals x dx, which is pretty easy to integrate. X squared over 2 dx. Great. Now we can use this. Okay. There we go. So, let's do it. U times v is the natural log of x times by x squared over 2, x squared over 2, right? And then minus the integral of v, x squared over 2, du, 1 over x dx. So this equals 1 over 2 natural log of x squared, okay, minus 1 over 2 integral of x squared over x dx. Do you see how we got the x squared? We moved the fraction here to the front as it is a constant, and then we just multiplied the x squared by 1 over x, which gives us x squared over x, okay? And we also moved this to the front because then it's going to be, it's more, we can visualize it, like we can see it, so it will be easier to remember that we need to factor that out at the end, okay? So here we can see 1 over 2 natural log of x, and then x squared, minus 1 over 2 integral of x dx, right? See? Because x squared divided by x is basically just x times by x over x, which you can just cancel 1 and you're left with x. So yeah, that's just a little bit of algebra right there, but let's finish this off. So this equals 1 over 2 natural log of x squared minus 1 over 2 times by x squared over 2. Okay, and then plus the constant of integration. Got it? So, can actually just do this 1 over 2 natural log of x squared, and then going to do minus 1 over 4 x squared. See, because we just multiplied these two by each other. Then plus oh dear, plus c. Great. Now we can factor out 1 over 2. Actually, we can factor x squared over 2. I think. Yeah. So, yeah, let's do that. So this equals equals x squared over 2 times by the natural log of x minus 1 over 2 and plus c. So that is a short introduction on integration by parts. I hope you enjoyed it. This obviously is a very rough thing, and I'm sorry if the quality wasn't great today, as I haven't posted for a while, so I'm a bit rusty at making YouTube videos. So I'll try and upload more often. But thank you for watching. I really appreciate it.